All right, this next factoring method you'll see crop up from time to time. Every once in a while, if you see this, you can just automatically do a quick check and do a factoring of it. Um, and again, this doesn't come up all the time. It comes up from time to time, so it is handy to always remember it and know it. Um, so here it is. So this is trinomial factoring of perfect squares. All right, so basically we've got these two forms which are nearly identical. We have a squared and b squared. We've got a squared and b squared. But notice that the second term is a positive 2ab here and a negative 2ab there. So these are the two variants that you'll see out in the wild. All right. And basically, whenever you've got the middle term is a positive 2ab, then you'll be able to factor this perfect square as a plus b squared. But if this middle term isn't a positive, if it's a negative, then you're going to be able to factor this trinomial as a minus b squared. Okay. So basically, if it fits this form and it passes a check, if it's positive here, it's positive there. If it's negative here, it's negative there. So what's this check? Well, the check is you take this value of A and you multiply it times this value of B times a positive 2. And if it equals this middle term exactly, then you can write it factored in this form as a perfect square. Or, if this ended up being negative in the middle term, you take A and you take B and you multiply those times negative 2. And if that is equal to your middle term, okay, which is negative, then you can write this expression as a perfect square with minus the difference between A and B. So, it's quickly looking and noticing this, checking to see if A times B times positive 2 gives you this middle term or not. The hardest part, maybe, of this is really just kind of remembering that. All right, so let's take a look here. I'm going to give two examples, and then I'll do the two think, pair, share. So after I give these two examples, you can pause this video and try the think, pair, shares yourself. Okay. So let's look at this first example. So in order to fit this form, okay, notice that we need some quantity squared in the first term, and we need some quantity squared at the last term. So 9x squared, we're going to have to rewrite that as 3x squared, right? Because 3x times 3x gives us 9x squared. But we have to be able to write 9x squared as some quantity, some term squared, because this will become our value of A in order for this to fit this form. Okay, then we've got plus 12x, and then 4 we can write as 2 squared. So this value of 2 is our B. So now what we want to do is take this value of A, which is 3x, this value of B, which is 2, and multiply that by a positive 2 as well. And let's see, what do we get? So 3x times 2 is 6x, and 6x times 2 is 12x. Well, that matches our middle term. So that means this can be expressed as A plus B squared, where A is 3x, and b is 2. All right. So we had to do a little bit of a conversion to get this trinomial into this perfect square form, and then do a little check to see if a times b times positive 2 gives us that middle term or not. Okay, let's try it with this one down here. So down here, we can write 16x as 4x squared, right? Because 4 squared is 16, and x squared is just x squared, okay? Then we have plus 24xy. And now this last term, we can write it as 3y squared, right? 3 squared is 9, and then we got y squared. That gets us back to that one. All right, so this is our value of a. This is our value of b. And so now we want to take the product of our value of a, multiply that times a positive 2, and multiply that times our value of b, which in this case was 3y. And 4 times 2 is 8, and 8 times 3 is 24, and we have x and y. So this product here is 24xy, which is exactly what our middle term is. So that means this expression can be written in this perfect square form. And our value of a was 4x, and our value of b was 3y. So this is the equivalent factored form of our original trinomial. Okay, so here I've given you 2 examples that you can try these 2 think pair shares on your own. So go ahead, pause the video now and give it a try. You can check your answers here too. All right, so let me give you my interpretation of the factoring of these trinomials. So we want to take this first term and write it as a square. All right, so 81 is 9 times 9. So we can write 81x squared as 9x squared minus 72x. And 16 can be written as 4 squared. So this is our value of a. This is our value of b. So we're going to multiply them together. So we've got 9x times positive 2 times this value of b, which was 4. And let's see here. 2 times 4 is 8, and 8 times 9 is 72. Okay. And x, and then we have an x. So we have, okay. And all this came out to a positive. All right, but we're dealing with a negative here, which means that instead of this being a positive 2, if we made this a negative 2 instead, that'll give us a negative 72. So this gives us the other variant of this, where this is going to fit the perfect square form, where it's a difference between a and b. Instead of being a plus, it's going to be a minus. And so a was 9x, and b is 4. There we go. So this is the factored form of that trinomial. They're equivalent. All right, let's look at this next one. So we've got 25q squared minus 120qr plus 144r squared. All right, so we can write 25q squared as 5q squared minus 120qr plus 144, we can write that as 12 squared and r. All right, and just like before, this is subtraction now. So I'm going to be throwing in a negative 2 there in the middle. Okay, so there's our value of A, here's our value of B. So let's multiply by -2 this time, times these values of A and B, like that. And let's see here, 5 times -2 is -10, and -10 times 12 is a -120 times Q times R. And that does equal our middle term. So that means this will end up being a perfect square with a difference between A and B in this form. And A was 5Q, and B was 12R. There you go. So this is the factored form of that trinomial. Okay, let me know if you have any questions.